We are now jumping into the world of equations. Let's first start off by defining what an equation is. An equation is a statement that two expressions are equal. So let's look at the following examples. A. Okay, so we have 2x minus 3 is an equation. Is this true or false? Well, in order for an equation to be an equation, it has to have an equal sign. There is no equal sign here, which means that no, it is not an equation. Now let's look at the next one. This one says 3 equals 5. Okay, well, 3 by definition is an expression. It expresses the number 3. And 5 is also an expression. It expresses the number 5. Although we know that 3 does not equal 5, this actually is an equation. This is an example of a false equation. Okay, but we can go ahead and write that this is true. Now the next one, we have 2x minus 3 equals 10 is an equation. Well, 2x minus 3 is an expression, and 10 is also an expression. And this equal sign is here, which means that we are in fact working with an equation because we have the statement that two expressions are equal. True. Okay, next it says a blank is a symbol used to represent one or more numbers. You've been using this since the beginning of the year and probably in elementary school as well. A variable is a symbol used to represent one or more numbers. And now let's look at the following examples. Identify the variable in the following expressions. Feel free to pause the video and try these on your own first. Okay, the variable in example A, we have the expression 2x. The variable is x. The variable in expression B, where we have negative 3m, the variable is m. Here, example C, we have 5m squared. That's the expression. The variable is m. The exponent is 2, but the 2 does not affect the variable. The variable is actually just m. D, we have the opposite of y minus 15. Well, the variable is just y. Okay, let's move on to the next thing. A numerical blank is the number that is being multiplied by the variable or some unknown quantity. This number is traditionally placed in front of the variables. What we're talking about here is we're talking about a numerical coefficient. So the coefficient is the number that's being multiplied by the variable, and typically it's written directly in front of the variable. Here are some examples. Feel free to pause the video and try these on your own. For example, E, we have the expression 2x. The coefficient is 2. For example, F, we have the expression negative 3m. The coefficient is negative 3. For example, G, we have the expression 5m squared. The coefficient is 5. Take note that this is the same as 5 times m squared, which is the same as 5 times m. This is not the same as 25m. The squared sign is only connected to the base, and the base is only m. It is not 5m. Now this next one's particularly tricky. When you have a variable that stands alone, there is a phantom 1 that's in front of it. And what that means is that there's one y. That's the same as saying, I went upstairs to Miss Shannara's desk where the fruit's being held, and I picked up an apple. Well, what you're saying is that you picked up one apple. You don't have to say the word one, but it is implied. So the coefficient when a variable stands alone, like in example h, is 1. Now the next one, we have the opposite of y. That's what we learned in the last unit. Well, the opposite of y is actually negative 1 times whatever y is. So it's again another phantom. This phantom dotted line that exists in front of the y, but after the negative sign. So actually, when you have a negative sign in front of a variable, the coefficient is negative 1, even though you can't see it. And now this other example, we have some things that are kind of tripping us up. We have this piece and then that piece there. Well, we're only trying to find the coefficient, and the coefficient is placed directly in front of the variable, and it's the number that's being multiplied by the variable. So the coefficient is actually negative 3. Okay, now the next part, number 4. A blank stands alone and is not connected to a variable. We will refer to this number mostly as the numerical blank. An addend is a mathematical term that refers to the numbers being added together in an addition problem. So really we're working with two ideas that are essentially, they're very similar but not exactly the same. So a constant stands alone and is not connected to a variable. So that's similar to what you've learned in science class. If you were approaching a problem and you had to identify your hypothesis and also identify any constants that existed. Those constants are very important, and they typically stand alone. They don't affect anything else. So the constant is not attached to a variable, and it stands alone. But we will refer to this number mostly as the numerical addend, because since we aren't subtracting anymore, instead we're using the definition of subtraction as adding the opposite. We're really only working with numbers that are being added together. These are actually terms, things that we discussed that last unit. But an addend is a mathematical term that refers to numbers that are being added together in an addition problem. And since we're naming the numerical addend, we're naming essentially the constant as if it were in an addition problem. So let's take a look at these examples. Feel free to pause the video and try them on your own first. So we have the expression 2x plus 3. Well, 2 is the coefficient, x is the variable, and 3 is the number that's being added. So 3 is our numerical addend. And the next one, we have the example negative 3m minus 8. Well, we can't really see what number is being added. We know that 3 is the coefficient. We know that m is the variable, but we're subtracting 8. Well, if we change subtraction to adding the opposite, we'll be able to identify the numerical addend. That numerical addend is negative 8. And the last one, there are actually 3 different addends. But first, let's go ahead and change the subtraction to adding the opposite so we can identify the numbers that are being added together. So the numerical addends are 9, 6, and negative 7. Oops, I wrote negative 3, but I meant to write negative 7. Okay, so now we have 2 more examples, and the problem states to identify the coefficient, the variable, and the numerical addend in the examples below. Feel free to pause the video and try these problems on your own. Now for the first one, the coefficient is the number that's directly in front of the variable, and in this case it is negative 3. The variable is the symbol that represents a number or a set of numbers, so m is equal to your variable. And the numerical addend is this 6. Now for the next one, instead of circling it, I will list it out. Let's first identify what the coefficient is. The coefficient is the number that's being multiplied by the variable, and that's 2. The variable is equal to m. And in order to identify what the addend is, we need to change subtracting 5 to adding the opposite of 5. So the addend, the numerical addend that is negative 5. Number 5 says solving an equation means that you are finding the value or values that. This is super important. So in the last unit we talked about replacement sets. And replacement sets were like these down here, where we're given a set of numbers and we're trying to replace that number n for n to see which value makes that statement true. So when solving an equation, you are finding the value or values, and this is very important. You are finding the value or values that make the equation true. You're finding the value or values that make this equation true. Okay? And you'll remember at the very beginning of this video, we had an equation that was false. This equation is false, even though it is actually an equation. We marked true here. This is a false equation, but it actually is an equation, which is why we wrote that 3 equals 5 is an equation. Okay? For this example, 2x minus 3 equals 10. There is exactly one solution to this equation. When you solve this equation, you will find one number that, when replaced for x, creates a true statement. So as a review, replacement set review, it says solve each equation using the given replacement set. If an equation has no solution with the replacement set, so state. This is a review, just wanted to go over it really fast. So we wanted to figure out which statement makes which value for n makes the statement true. Well, if we do 8 plus 9, does that equal 18? No. What about 9 plus 9? Does that equal 18? Yeah, that does. What about 10 plus 9? Does that equal 18? No. And 11 plus 9, does that equal 18? No. So the only solution would be n equals 9. And the next one, if we were to replace m with any of these numbers, we would say 10 is equal to negative 5 times negative 2. Is this true? Well, yeah, 10 equals 10, so therefore, yeah, that works. We found it on the first try. But let's go ahead and plug everything else in. This one does not work. And let's try this one last one. Negative 5 times 3, well, negative 15 does not equal 10, so that is wrong. So the only one that works is when m is equal to negative 2. And this concludes our introduction.